Hey guys, Emerson here, Math for Teachers 2, and this is my self-presentation. Today we're going to go over Chapter 8, which is Algebraic Reasoning, Graphing, and Connections with Geometry. So we're going to go ahead and take a look. So the first problem we are going to explain the graph using the scenario and the functions. So let's read our scenario. How does the graph correlate with the function of the amount of gas in a gas tank when a driver refills the tank on a trip? So we see that our y value is gallons in gas, and we get that, when we are labeling our x and y value, it always comes from the scenario. So we always like to tell students that, you want to reread a couple times, highlight and underline, and just label the best you can. So my guess was gallons of gas, and I also got that from the scenario. And then, when you drive a car, we drive at miles, So what's going to happen is we see that this point right here is where the driver has gas in his car, but then he drives all these miles and then ends up on E, correct? So he goes to the gas station and he fills his car back here and gets way up here. Notice how he didn't go anywhere. He just filled his car up, which is the y value right here. That's the y value. And then down here is the x value. So you see how the gallons of gas rises when he fills the car back up. And then the more miles he drives, you see how the gallons of gas go down. So using that gas, he's back onto E. And if he was to fill the car back up, you would see how it'd go back up, and then the more miles he would drive, it would go down. So that one was pretty self-explanatory. Not as bad though. So let's take a look at another one. So this one we're going to explain the graph. We're going to correlate the function of the height of an elevator at a stopping point, stopping at each floor on the way up. So let's take a look again. So we see we have the rise of the elevator as the y, and then the time on the elevator as the x. And I mean, that doesn't have to be necessarily on the elevator, or that, it's just time in general. The time period it takes it to stop, either way you go, it's rising. That the time is rising as the elevator rises. So we're going to label this floor 1, floor 2, because, on an elevator, you use an elevator to go to certain floors rather than taking the stairs. Floor 4, and then floor 5. Sorry, that floor looked a little funky. All right, so we see on the first floor right here, we see that it is rising. To get to a stopping point, the time on the elevator right here of letting people off and letting people back on, push their buttons to get to whatever floor they want. And then once the elevator starts rising, it's going to go to the 3rd floor. Stop, let people on, get off, go up to the 4th floor. Stop, people, let people get off on the 4th floor. And then it's going to go up, stop at the 5th floor. And that's going to be a continuous process, and it's going to be the same way going down. They're going to go down, stop people, let people get off on this floor, go down, let people get on and off on that floor. And then, this one's a lot more comprehensive and has a better understanding of it. It kind of reminds me of rise over slope, because, our rise of the elevator, and then our slope would be time. So this one we're going to explain the graph with the correlation of the function of a height of a bouncing ball dropped from a table. So here I put, instead of putting height, I put the range, which, I mean, it's just a bigger word for height, but it's really just the range it bounces from the ground. So we see we have our bouncy ball here, and it hasn't been dropped yet. But once it drops, it's going to go down, and then once it hits the floor, it's going to bounce right back up. We can see this from our graph. It's going to go down and then bounce right back up. But we got to remember what our x and y's are. So our x is representing time, right? So that means the longer that it's bouncing, the smaller my range is. And you can see that whenever I hit this animation. It bounces, and it's going to go slower and slower and slower. And that, and that would just keep going until it just didn't bounce anymore. So that one also you can see in this image as well. It's going to bounce, and then it's going to then it's going to go back up, but as the time goes, it's going to slowly start bouncing and the height of it won't be as high. So this one, we are going to explain the graph of a flagpole, shadow of a flagpole. So how does this graph correlate with the function of the length of a shadow of a flagpole throughout a sunny day? So this one I feel like is a little bit more tricky and harder for, students to understand. So like I said, we always want to go through here and you want to know the length of a shadow and then throughout a sunny day. So, throughout the day represents time. Length of a shadow is the height of it. Basically, you could just say the length, the height, it's just all measurements. So, y, then we have our x here. So we have our flagpole dead in the middle here, correct? So we know if the sun comes on this side from over here, we know that we're going to have that length of a shadow. All right, when the sun is in the middle of the flagpole, then we know that there won't be any shadow. When it's directly over it, there's not any shadow. So we see that from right here. And then we see once the sun's on this side, it's going to start setting. But once it starts setting, it's still going to have a shadow going this way. So that one's a little bit more tricky. So as you can see, the sun's on this side of the flagpole of our description over here. Sorry, my suns aren't really pretty, but we see if the sun's overheaded the flagpole, we see that it's going to have this length. That one was a little bit more tricky, and I don't expect my students to just be able to get it when they see it because, some people are visual learners, some people, can read an example and then understand it. So then this just gives you a little bit of both of the background. So we're going to take a look at functions. Excuse me, sorry, my throat. So let's take a look at function. We're going to explain the functions in this chart and see how it relates to the graph here. So we see that we have, let me get my pen back out. We see that we have our table of x's here. This is where our table of our x's are. And we're giving all these numbers. And then we're giving two functions. You see that right there? See how we're giving two functions? And then f of x just means y, so we could just cover f of x up because it's a little scary, which just equals y. So, now looking at the table, we see that we have two different lines from this one chart. See, this table right here is going to give us points for x, and then both of these charts right here are going to give us points for y. So that's giving us two different lines. But we aren't necessarily going to look at that right at the second. We are going to look at the function. So let's look at this. We see we have our x's, correct? And a function is just equal to y. So what we do here to solve for our functions, we just plug in x to get our y. It's like plug in your input and then you'll get your output at y. Plug in your input at x right here. See, f of x is just really y. Don't know why I took that off. So we see that's 0. So we're just going to replace that x with a 0. 3 times 0 is 0. And then, that could just be continuous. 3 times 1. Right here, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So, it looks a little complicated, but really, it's actually fairly easy. So let's look at the next chart. Let's look at the next table. So also y, and we see we have our x's here, still the same, 0 through 3. And all we're going to do is plug those in our x, and it gives us an input for x and gives us an output for y. So let's see 0. 0 times x, f of 0, which is x, plus 8. So, 0 plus 8 is 8, and then we have 1. So we have 8. Sorry. So you guys see how that correlates to here. And then we see that after that, we're given our points. So here's our first set of points. This will give us our first set of points. So it'd be 0, 0, which is right here on the chart. And then let's look at here. Let's see if we can get examples. So we have from this table 0, and then we have from the other table y. So 0, 8. Excuse me, I said y. 0, 8. So we have 0, and let's see if it goes up to 8. It does, right there. And then we have 1 for the x, 3 for the y. So let's go to 1, and then we see how these are 3, because this is an understood 3 right here, because when we go by 2s, we already know that there's numbers in between those. So our number there would be 3. So, and then we have 1 and 11. So we're going to go to 1, and then we're going to go to 11 again. We know that there's an 11 and half right there because we're going by 2s. So, that's not as difficult as it may seem, but it can get very, very complicated and messy real quick. So we just want to make sure that we're labeling our charts right and graphing correctly. So let's take a look at this. We're going to start looking at how to find the slope. So the slope is the change of y over the change of x. And if you look up here to the right corner of my screen, you see that these little triangles here, those are just mathematical terms for change. That just means change. So that's how we find our slope. Or you can just say rise over run, which it's both pretty comprehensive. I like change of y and change of x because it makes more sense to me to see what's changing in them. So I used a right triangle as my example right here, so we could visually see what is changing here. So if we go down here to 3, this is our y, let's not forget, and this is our x. So let's go down here to number 3, and we see the point here is 3, 1. So, and these are in ones. So we know there's 1, 2, 3, 4. So we know that the y changed 4 times. So we can go ahead and just put 4. Sorry, you might not be able to see that. So we're just going to go ahead and change of y, which is 4, which is also known as the rise because it's increasing or decreasing. It's the rise of it. So it's 4 and then 1, 2. 4 over 2. And that's the change of x, which is also the running across the x-axis. And then simply you just use math from there. 4 divided by 2 is 2. So 4 divided by 2 is 2. So then we know that our slope is a positive 2. Again, doesn't seem very difficult, but can be frustrating sometimes. So we're going to find the slope here. We see that there's multiple ways to find the slope. Change of x, change of y, rise over run, which I just think, that's a more easier method, but you can also, you can use slope-intercept form to find your slope. You can do all of it. But looking here, we see that we have our table and our graph. But if you take a look at our graph right here, where I just put that arrow, take a look at our graph, and we see that we just have a vertical line, straight line. There is no run across the x-axis for this. So if we were just doing rise over run, we would see, whatever the change of y was here, but the change of x is 0, and we can't have 0 as our denominator. So we could, just by looking at it, we already know the slope is undefined. But let's take a look over here. We see that we can find the slope by using this method right here. So y2 minus y1 divided by x2 minus x1. So, and if you're wondering where we get these points, we get those points from our data table charts, and that goes for any data table charts. If you just want to make sure, you're doing it right, or, the slope's undefined, but you just want to make sure. I mean, pretty visual, but again, can always find a way. So we see that our y2, which is right here, this is 2, this is y1, this is x1, this is x2. So our y2 is -8, so we plugged in -8 right here. And then we're supposed to subtract the y1, so subtract +8. So here we go, and then that gives us a -16. All normal, that's fine. We can have a rise of -16. But when we go to do our x's, we see, x 2 right here. We get that from over here in our data table chart. We plug it in right there, minus positive 5 minus positive 5 is 0. So again, you see that our slope is 0 because we can't have a 0 as a denominator. If it was the other way around, I mean, it would still wouldn't have a slope, but, you know, obviously we could divide 0 by something, but we can't divide something by 0. So we know that our slope is undefined. Again, there's many ways you can find that out, but, you know, just but you know, you could just look at it and tell, oh, it's a straight line. It doesn't have a slope. It doesn't run. It doesn't go on the x-axis. It doesn't move. So just an easy way to remember. So again, we're going to try to find the slope here. So again, I use the right triangle because I think it's a good visual aid to be able to see, you know, what our points are that are moving. So we're just going to simply do rise over run since we've seen the other method. So we just see, if we take a look, we see that we're going by 2's down here, correct? All right, so we see 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be a rise of 9 over whatever the run is. And we see the runs are going by halves as well. Or are going by halves as well. So 1. Excuse me, let me erase that. I told you incorrectly. Okay, so actually this is just 1 because we're not going by 2's, we're just going by 1, so we're not going by halves. So here's 1, 2, and then 3. So our run was 3. So 9 divided by 3 equals 3. That's pretty simple. So again, can be very, very confusing. We just, you know, that's just a simple way to do it. We can always look at the chart, the graph data table over here on the left, and we could find it that way. Or we could do slope intercept form, or, you know, we could even do it like using lattice points, but this is just the easiest way for me to visually see it. See, 9 divided by 3 equals 3. So that does check out. We did do that correctly. Okay, we're going to take a look at parabolas. So parabolas are the same line, just at different points on the y-axis. So if you can look at the graph, we already see that knowing off. Let's take a look at our data table. So we see, you know, again, we're given all these x values right here. They don't change, just our y value changed. So we see we have y equals x squared. So we put in -3 for x. -3x squared is 9. -2x squared is 4. -1x squared is 1. 0 is 0. 1 is 1. 2x squared is 4. And then 3x squared is 9. So we see how that works out, right? And then we see that we have y equals x squared plus 7. And excuse me, these top halves are actually supposed to be negatives. I'm sorry about that. I forgot to put the negative sign. All right, so sorry about that, guys. So sorry about that, guys. Yeah, those were supposed to be negative. And so, and we see, you know, x squared plus 7 gives us all these numbers right here to 0, and then gives us all these numbers right here. And then they're the same numbers. And then we see -7. So this would give us our negative numbers. And then if we take a look at the graph, we see that we are at 7 right here. 0, parabola of 0, parabola of 7, positive 7 right here, -7 right there. And we can see all of our points that are on the data table chart along with this, but the main focus is right here, our -7, our positive 7, and then just x squared right there. So not as difficult as we see. But, you know, like I said, it is very, very, very confusing. I'm sorry about my mistake there, guys. So, looking at perpendicular lines, let me move me so you guys can see. Looking at perpendicular lines. All right, this one's a little tricky, but not, you know, not complicated if we make it. So this right here in blue is what we were given. We were given y equals negative 3/4 plus 5. And what we're doing is we're trying to find the slope for that. And we're given the points 6, negative 1, which are on the chart right here. So that gives us help to make sure we're finding the right slope. So our original slope from seeing right here, this is mx plus b. This is slope-intercept form, mx plus b. Like I said, very easy to find because you know our mx is the slope. So here's our original slope. What we're going to do, like we did earlier, is we're going to find our new slope for our other line, which, like I said, this gives us two different lines right here. Our perpendicular lines are right here. Gives us, the chart has two lines in it. Even though it's one chart, it still has two sets of points for each line. So we see y minus y1 equals m times x minus x1. Well, that equals 4/3. So all we're doing there is finding the negative reciprocal. So let's go down here. Y minus parentheses negative 1, that's from our y1. And then equals 4/3, which is from our m right here. And then times x minus 6. And we're getting these numbers right here. We're getting these numbers from a point that was given. So what we're trying to find, I mean, it's not necessarily the new slope, it's more of the new line. Maybe I shouldn't write slope. You can find your slope in this, but it's more of a new line. It gives us our new points to find our slope. So we are going to add 1 right there. We're going to do plus 1. And then plus 1 right there. And then that'll still x minus 6 times 4/3 gives us 4/3 x, because we multiply, we distributed that right there, and we distributed 4/3 right there. So it gives us 4/3 x minus 24/3, because 4/3 multiplied by negative 6 is negative 24/3. So we still have y plus 1 right here. So we were trying to get y by itself to find our line. So we're going to subtract by 1, and then that'll give us 4/3 x minus 8, which will actually give us, we're actually going to, basically, when we're subtracting negative numbers, it actually gives us still a negative number, but it gives us a higher number, more away from 0, not closer. So we are going to end up, after negative 8 minus 1, that'll give us a negative 9. So our new line right here will be y equals 4/3 minus 9, and that's right here. And then we could see our perpendicular lines on this data table chart. And that's plugging in all the points from our table. See, not very hard. I mean, it is hard. It's hard if you don't understand. But if you look at the table and you look at our graph, we can see how our points, like I said again, this is x. This is x for everything. So that's why the line looks so similar. The only thing that changes is our y values, our outputs, because we're going to put in the same input, which is the x, and then we're just going to get different outputs for different functions. But they're still perpendicular lines, and they're still and they're still the same. It's just different y values, because as you can see, the y values are changing on the graph. So let's look at some more perpendicular lines. So again, we are given this right here. We are given 2y plus 9x minus 5 equals 0. And then we're given these points 0, 3, which is the point S. So what we're doing here is we see our slope-intercept form right here, y equals mx plus b. So we have our 2y plus 9x minus 5 is equal to 0, correct? Well, y equals negative 9/2 x plus 5/2. And then that makes our original slope negative 9/2. And what we did is that we used the slope intercept form to find that. We did mx plus b, but I just skipped all of that since we seen it in the previous slide. I just didn't want to make it more complicated and confuse you any more than what you already were. So again, we're going to solve with this. So we have y minus y1 equals m times x minus x1 equals, that'll give us m equals 2 over 9. So again, we're getting these numbers from our points up here that are given to us, point S. So y minus 3, which is right here, which is y1, this is x, and then this is y. So let's remember that when we're looking at this. Y minus 3, because that's positive, we're supposed to be subtracting, so it gives us a negative 3, equals 2 over 9, which we're getting that from right here, which is m, times x minus 0. We're getting 0 from x right here. We're getting 0 from there. So we see y minus 3, and then we did what? Did x minus 0, and that'll just give us 0. So we did y minus 3 equals 2/9 minus 0. And then what we're going to do is we're going to add 3 to get y by itself. So add our 3's, and then that'll give us 2 over 9 plus 3. And we get that right here in our data table chart. And this is what we were given. And this is in slope-intercept form. That's what we were given. We had to solve for that because this is actually what we were given. And then, let's see if 0, 3. And then that is on there. So let's look at our perpendicular lines. Again, it's really just, now it's just the x value that are changing because we have what our y equals. Alrighty. So now we're going to look at tangent lines. And tangent lines are a little bit different. So we're actually not looking at tangent lines. I mean, we are looking at tangent lines, but right now we're going to focus on the radius. So before we even try to find the radius, we got to know what the center of the circle is. And the center of the circle, I just made it easier to do this one because it's 0, 0. And that's just, center of the circle's 0, 0. That's the middle. So if we have a radius 9, so our question was radius 9 at 0, negative 9. Let me move me so you guys can see this table a little bit better. Sorry about that, guys. Oh, and I just clicked on the line. Okay. Sorry about that. Maybe a little bit more. So a center of a circle is 0, 0. Correct? That's the middle right here. That's this point. That's the center of the circle. So if we look, we see that our slope is 0 because it hasn't gone anywhere. Remember what we talked about? If there's no rise and no run, then the slope is 0. So what we're going to do is we're going to do y minus y1 equals m times x minus x1. And that'll give us m equals 0 because that's our slope. M is our slope. So m equals 0. And so now we're using the points right here that we were given just like we were. Just like we were for perpendicular lines. This is just trying to find the radius. So the radius 9, center is at the origin. So y minus negative 9, which we put negative 9 in parentheses because we just have 2 subtraction signs outside there and it gets kind of confusing, equals 0 times x minus 0, which is just going to be 0. And what we're going to do here is what we see 2, negative signs. We know 2 negatives make a positive. Excuse me. We are going to, it is positive. That makes it a positive 9. But what we want to do is subtract it. So we're going to do negative 9 minus 9, which makes it negative now. Sorry about that. That might have confused y'all. So we're going to do negative 9. So if we had 0, and we already know that equals 0, we're just going to end up with negative 9. 0x minus negative 9, which just gives us y equals negative 9. Right here. So let's go look at that. Y equals negative 9. So that means our radius is 9 because we see that no matter the rise or the run, there is no rise or the run, but we see that every point of this circle ends at 9, whether it's negative or positive. So let's look at our line at -9 though. See what that line looks like. We know that when it's on the y-axis, it's going to go through the y, and when it's on the x-axis, it's going to go through the x-axis. So our line should be horizontal, but let's take a look and find out. It is horizontal, so it doesn't go anywhere. It's just barely touching -9. It's not going to touch any other point on that y-axis but -9. So that checks out. We did pretty good. So let's look at this one. We kept this line so we could see it, because what we're going to do is we're going to compare our tangent lines here in a minute. So, but now we're going to do +9 at the radius. So let's see if that, and you know, negative numbers, all it is that the sign in front of it is different, but the numbers don't really change. So it should look the exact same, but what we're going to do is we're going to find out and make sure. So let me just show you how we got, let me show you the equation of the radius here. So again, y minus y1 equals m, which is our slope, times x minus x1. Well, we already know that our slope is 0 because the line's not going anywhere. So y minus 9, and we're getting that from these points. Remember x, and remember our friend y. So we want to know y minus y1, which this is y1. So y minus, and then it's positive, so put it in parentheses. You don't really have to. I just like putting stuff in parentheses because I know that I inserted that, and I know that's supposed to represent something. So that represents y1 right there, equals 0 times x minus 0. Well, we're getting this minus 0 right here from our x1, which is the 0 up here. So y equals 0x plus 9. You will know what we did there. Since it was negative and there's no other, we're going to add that to the other side because we want to get y by itself. So we're going to add 9 to the other side, and we're going to end up, I'm so sorry, that's so ugly, guys. And we're going to end up with 0x plus 9. Well, 0x plus 9 is just 9. So our y equals 9. So that means at our center, it should only just go up to +9. And it does. That's all it goes to. And like I said, remember, all the way around the circle should just be 9. That's what a radius means. It means that the circle is not bigger than 9. No matter what point you go to, or, no matter what edge you go to, it does not get any bigger than 9. So let's take a look at our other line. So like we said, it should look the exact same, but the sign is flipped. It's a positive. So it should be up there at the top, and it also should still be a horizontal line. So let's double check and make sure we did that right. And it does. All right. So we have 2 tangent lines here. Well, we know we're looking at that and we see, all right, if our radius is 9, that means these tangent lines look parallel. So meaning, with that being said, we see that you see those 2 lines are parallel, and we see that these 2 lines would also be parallel, right? If the radius is 9, all of our lines should be equal. There should be no lines going through this circle. It should be equal all the way around the circle. Not necessarily a square per se, but the points should all be equal. So meaning that these points touching the line are all equal, whether it's negative or positive. That means the radius is 9, and we got to make sure that we're doing that right. Well, thank you guys. See you next time.